Hello, my little mathematicians. Today we're going to explore what happens if a dimension, or another name for a side length of a figure, dimension means side length. What if a dimension is doubled or tripled? How does that affect the overall area of a shape? And for the fun of it, since I know you love math so much, I'm going to throw in perimeter as well. Okay. So if you would turn to page 18 in your packet, you can follow along, and that would be great. And remember, you're always welcome to pause the video, try it first on your own, and then unpause it, press play, and follow along and see if you got it right. Okay, for the first one, we're asked to find the area of this shape right here. Okay, well, the area of a parallelogram is base times height. So I look for that little box indicating a 90 degrees, and that connects your base to your height. So my base is 5, my height is 3. Okay, the 6 is used in case I wanted to find the perimeter. Okay, so my area is 5 times 3, 15 inches squared. Okay, and that's it. That's all there is to it. Now, in case I wanted to find the perimeter of this figure, well, let's go ahead and take a look right here. The perimeter isn't an exact formula. It's just always the outside edges of a shape. So look for the dark lines. It's never the dashed lines. Those aren't a part of the actual shape. So it's 5, 6. This is also 5, and this is also 6. Okay, so all along the outside is just 5 plus 6 plus 5 plus 6. If I go ahead and add all those together, well, 5 plus 6 is 11, and that 5 plus 6 is also 11. So my perimeter is 11 plus 11, which is 22. And when it's perimeter, it's just inches. Area is inches squared. Perimeter is just inches. Okay. Let's go ahead and take a look at our next shape. This is a triangle, so let's write the formula for area of a triangle. That's 1/2 base times height, or base times height divided by 2. Okay, either way, same thing. Look for that little box that indicates a 90-degree angle. That connects your height to your base. So my base is 6, my height is 2, and I put that over 2. You can go 6 times 2 is 12. 12 divided by 2 is 6. Or you could have simplified, and 3 times 2 is 6. Over 1 is just 6. Either way, regardless of how you did it, you should have gotten the area of your triangle to be 6 feet squared. Okay. What if I was asked to find the perimeter of that triangle? Well, again, just look for the outside edges. Before, it was a parallelogram, so that means it was a 4-sided figure, so there was 4 edges. This is a triangle, so there's only 3 edges. So I'm going to only add 3 sides, 3, 6, and 4, as those make up my outside edges of my triangle or figure. Add those together. 3 plus 6 is 9. Bring down your plus 4. And 9 plus 4 is 13. And perimeter is just feet. Okay, these were pretty basic problems. We already knew how to do these. But what if they gave me a word problem and they suddenly said, all right, you did this problem. What if this parallelogram from problem 1 had each dimension doubled? So that means when I'm going to find the area, okay, it's still base times height. But this time, instead of my base being 5, I'm going to double that length and have it be a base of 10. So I'm going to plug in 10 for my base length. And then my height, well, my original height was 3. If I doubled that, now my new height is 6. So let's plug in a 6 for my height. Okay, go ahead and simplify. Either do it in your head or in your calculator. 10 times 6 is 60, and it's inches squared. Okay. For my perimeter, it's just the outside edges. So this was 10, so is this. Okay. So 10 plus 10. But I don't know this edge, so I need to look back at my original shape. If this was initially 6, go ahead and double that. That would make this 12 and this 12. So you have 12 plus 12. And notice how I added these differently than I did in the first time. The first time I went 5 plus 6 plus 5 plus 6. You can do it that way, or you can do the 5s together and then the 6s together. Either way, regardless of when you add them, you'll still get the same answer due to the commutative property. Okay, 10 plus 10 is 20. 12 plus 12 is 24. Go ahead and add those. 20 plus 24 is 44, and it's just inches. Okay. Very similar. We're going to do the same thing, but this time to the triangle. So if I have area of a triangle, go ahead and always, always, always write your formula. Okay. And my initial base of my triangle was 6. So this time if I double it, I want it to be 12. So let's plug in a 12 for my base. And my initial height of the triangle was 2. So if I double that, my height is now 4. Okay. Did I forget something? I did. I didn't put it over 2, right? And that's why it's always so helpful to write that formula at the top, because if I see that, then I won't forget it. Versus some people are just a little lazy, let's face it. They don't write the formula, they just do this part, and they just go 12 times 4. Uh-oh. Okay, so let's go ahead and simplify this guy. 2 divided by 2 is 1. 12 divided by 2 is 6. So you have 6 times 4 is 24. Over 1 is just 24. And this was in feet. So when I go to write my area, it is 24 feet squared. For the perimeter, okay, I already doubled this side. This side was initially 4, so now it's 8 feet. And this side was initially 3, so now it's 6 feet. Let's go ahead and add all those, okay? So you have 12 plus 8 plus 6. Well, 12 plus 8 is 20. Bring down your plus 6. And 20 plus 6 is 26, and it's just feet. Okay, so these were our original shapes. Here, we did each dimension times 2. This time, for our next ones, we're going to take our initial shape and we're going to take each dimension and multiply it by 3, because it says we're going to triple each dimension, and triple is another name for multiplying it by 3. So if I go ahead and look at that very first shape, the parallelogram, my initial base was 5. Well, if I triple it, 5 times 3 is 15 inches. And my height was initially 3, so 3 times 3 is 9 inches. Now your area, base times height. Well, my base is 15, and my new height is now 9. Go ahead and use your calculator and type that in. 15 times 9 is 135. And my unit was inches. Okay. Same shape, but this time we're going to find the perimeter of it. Okay, if my initial base was 5 and I multiplied it by 3, I got 15. Okay, well this side was 6, so 6 times 3, this is now 18 inches, which means this is 18 inches and this is 15 inches because it's the same as this. You can go 15 plus 15 plus 18 plus 18, or 15 plus 18 plus 15 plus 18. I think it's easier to do 2 of the 15s and 2 of the 18s, right? Okay. Well, 2 times 15, or 15 plus 15, is 30. And 2 times 18, or 18 plus 18, is 36. Now go ahead and add those together. And 30 plus 36 is 66. And it was inches squared, or just inches? What do you think? Well, it's perimeter, so it's just inches. The only time we put squared is if we're talking about the area. All right, we're on our last problem on this page, page 18 of our packet. Okay, it's a triangle again, but this time we are going to go ahead and find the area of each side length if it was tripled. Okay, so first of all, always, always, always write your formula for area of a triangle. Okay, and if I look back way up top to my initial triangle, okay, my initial triangle had a base of 6. Well, 6 times 3 is 18, so this is 18 feet. Okay, so I'm going to plug in 18 for my base. Now I need to find the new height. Well, my initial height was 2, so 2 times 3 is 6, so my new height is 6 feet. Did I forget something? I did. I need to put it over 2. Okay, and then go ahead and simplify. 2 divided by 2 is 1, and 18 divided by 2 is 9. 9 times 6 is 54, and 54 over 1 is still just 54. So this is 54 feet squared. Okay. The last thing I'm going to ask you guys to do is to find the perimeter of the triangle if each dimension was tripled or multiplied by 3. So go back up to my initial triangle. We already did the 6 times 3 is 18. Well, 4 times 3 is making this new side 12 feet. And then this side length is 3, so 3 times 3, this new side length is 9 feet. Okay, so the perimeter, 18 plus 12 plus 9. Okay, now you could just do this in your head, but a lot of people make the trap of thinking that that's 20. They do silly mistakes. So I say, if you can use a calculator, why not plug it in? 18 plus 12 plus 9, and you get 39. Okay, and it's feet. Okay. Another thing, people become overly confident when they're allowed to use a calculator, and they make really simple mistakes. So I strongly suggest that when you hold a calculator, you don't hold it like this and use your thumbs, because unlike a cell phone, there's no Siri to autocorrect for you, okay? Clumsy thumbsy will not get fixed, so you'll sadly get the incorrect answer if you accidentally type the wrong thing. Also, sometimes previous answers are stored. So always make sure you clear each thing, put it flat, and use just your pointer finger when you're typing in numbers. Okay, once you get your answer, write it down, and then hit the clear button one more time, or maybe several just to be safe, and then type it in one more time just to be safe. Make sure you get the same answer in your calculator that you got the first time. And if you get the same answer twice, odds are you got it correct, okay? Just trying to protect you, because a lot of times people rush through using the calculator and they just trust it that it's right because, hey, a calculator doesn't make mistakes. True, but you are the one typing it in, so make sure that you typed it in correctly. Okay, so that's just my helpful hint for you. Now, before we close off this video, I want to point something out to you. Let's take a look at the areas of the parallelograms. Okay, so here's the parallelogram area, here's the parallelogram area, and here's the parallelogram area again. Okay, you can of course always do exactly what we did and find it the real way, but what do you notice between this relationship and this if you were to divide it? 60 divided by 15. Go ahead and type that into your calculator. What is 60 divided by 15? It's 4. Okay, well, if we took each side length, which was 2, and we squared that, 2 squared is 4. So if you take your initial area and multiply it by 4, you'll get your new area. So see if you could figure out what we did here then. Okay. Well, if each side length, instead of being doubled in this instance, this time they were tripled, and you're finding the area, so go ahead and square that. 3 squared is 9. So if you take your initial area and multiply it by 9, what do you get? What's 15 times 9? Go ahead and plug that into your calculator. Would you look at that? It is 135. Now I wonder if that only works for parallelograms. Does that work for triangles too? Well, let's check. Okay, here is my initial triangle. It had an area of 6 feet, and this had an area of 24, and this had an area of 54. Let's see if that same pattern fits. What's 6 times 4? 24. What's 6 times 9? 54. Would you look at that? So does that same pattern work for the perimeter then? Okay, well, let's see. We have our perimeter of our parallelograms. Okay, so 22 times 4 is not 44. See, let's look at that. 22 times 4 isn't 44. I mean, 15 times 4 gave me this one, but why didn't 22 times 4 give me this? Because when we do the area, it's squared, right? So I took that initial value and I squared it when I found the area. But here, when it's perimeter, you're not squaring it, so just do what you did to each dimension. If you double each dimension, that's multiplying it by 2. So 22 times 2, 44. 22 times 3, 66. All right, let's see if that pattern continues. Okay, my initial triangle was 13 feet. My when I doubled it, I got 26, and when I tripled it, I got 39. Let's see if that same pattern holds. 13 times 2 is 26, and 13 times 3 is 39. So if you can remember that nifty trick, once you find the initial one, if you're doing the area, whatever you did to each dimension, if you doubled it, that's multiplying it by 2, square it, and then you just take your initial answer and you multiply it by that. Okay? Or if you triple it, that's multiplying it by 3, square it, which is 9, and multiply your initial answer times that. But if it's just the perimeter, you're not doing the squaring part, you're just taking your initial answer and multiplying it by whatever you did to each side length. Now that is actually a lot to remember. So you can just do it exactly how we did it. We just doubled each length and we plugged it into the formula and found it. That works fine. Okay, that's a great way of doing it. Some people are more visual and enjoy doing it that way. Other people remember the trick. Okay, now if it asks you specifically on a problem, hey, what is the relationship between this area and the new area? And they're like, oh, it's quadrupled, it's multiplied by 4. You could find it the same way that we did and just go 60 divided by 15 is 4, and 135 divided by 15 is 9. So you take your initial area and multiply it by 9. You could have found that out, okay? And just in case, I mean, if it's a very big, important test, you can always work it out this way and then double check yourself. But if you have a steel trap memory and you remember that formula and those little tricks, great. This is a very difficult concept. I'm very proud of you for mastering yet another thing. If you want more practice, it's very easy to go ahead and just draw more shapes. And then why don't you explore, does this pattern hold up? What if you multiplied each side length by 4 or by 5? See if that pattern still continues. All right, congratulations, my little mathematicians, at mastering yet another difficult math standard.